Hi everyone, and welcome to our practice lesson on ohmic and non-ohmic devices. The difference between an ohmic device and a non-ohmic device is that an ohmic device has a constant resistance. A non-ohmic device has a varying resistance. So an ohmic device, basically no matter what amount of current you put through that device, its resistance won't change. However, with a non-ohmic device, a device that might heat up or resist the flow of charge, you'd get a higher resistance with higher current, or perhaps a lesser resistance. The main thing to remember is a non-ohmic device has a changing resistance. You can tell the resistance is either constant or varying by looking at a graph of the current over the voltage, or the voltage over the current. If the graph shows a straight line for a component, so the yellow line here is supposed to show the amount of current that flows through X over here, depending on the voltage we put across it. If that line is straight, that means it is an ohmic device and it has a constant resistance. The reason that is if we have the equation V equals IR and we keep R constant, if we divide both sides by I, we get V on I equals R, and if we then take both sides to the power of -1, we get I over V is equal to 1 on R. Now I over V is actually the gradient of this yellow line here, and 1 over R, if R is constant, the gradient will also be constant. So if this is constant, the resistance, the gradient of the line will be constant. We'll get a straight line on the graph there. However, if R is changing in a non-ohmic device, that's what happens, resistance changes, we expect a not straight line, say a curved line, as shown for component Y. Using the information on this graph, we're going to solve for all the typical values of this circuit over here, so the voltage across these components, the current, and the voltage of the battery. The first question, question 1, tells us that there is a current of 8 milliamps flowing through X. So the current flowing here is 8 milliamps. The first question asks, what is the current in Y? Since there's only one track for those charges to move through, one path, the current in Y is also going to be 8 milliamps. So not a tough first question there. The second part of the question asks, what is the potential difference across X, or the voltage across X? Going to our graph over here, this tells us that when there is a current of 8 milliamps, since this is in milliamps here, so 8 milliamps flowing through X, if we go along this graph here to this point, we find that we get a current of 8 milliamps flowing through X when there's a voltage of 1 volt across it. So the voltage through X is equal to 1 volt. The third part of the question asks, what is the potential difference across Y? Well, we know that there is 8 milliamps of current flowing through Y. So if we take this part of the graph here and move across, we can find the voltage through Y there. And it turns out that at a voltage of 1.75 volts, Y will experience a current of 8 milliamps. So the voltage through Y is 1.75 volts. I didn't say millivolts. 1.75 volts. It experiences a current of 8 milliamps. And the fourth part of the question asks, what is the voltage of the battery therefore? Well, the voltage of the battery has to be enough to supply both these components. That comes to a total of 1 plus 1.75. The voltage of the battery is 2.75 volts. That's question 1. Question 2 gives us a slightly different bit of information. So forget those values because they're all going to change. Question 2. It says that there is a potential difference across Y of 2 volts. So the voltage across Y is 2 volts. And we're going to solve for the voltage across X, the current through these components, and the voltage of the battery, just as before. So if there is a voltage, a potential difference of 2 volts across Y, we go to this graph over here, and we find that when we apply a potential difference of 2 volts to Y, we get 10 milliamps of current flowing through. So before we had the current and we found the voltage, now we have the voltage and we're finding the current. So if there is 2 volts across Y, the current will be 10 milliamps. I hope I said milliamps. I feel like I'm messing up milliamps and millivolts here. 10 milliamps is the current. If there is 10 milliamps of current going through Y, there must also be 10 milliamps of current going through X. Let's find out the voltage across X now. If there is 10 milliamps of current going through X, then there must be 1.25 volts of potential difference across X, according to this point here. So voltage across X is 1.25 volts. And therefore the total voltage of the battery is 2 plus 1.25. That's 3.25 volts. Notice this is higher than the voltage we had before for the question 1 circuit. And since the voltage of the battery is higher, we actually do get more current flowing through the whole circuit. It's 10 milliamps as opposed to 8 milliamps. Now question 3 actually changes the setup of the circuit. It assumes they are now in parallel with X here and Y above. Before they were in series, now they're in parallel. So we expect the behavior to change somewhat. So that was X and this is Y. Y and X. The only information we get here is that the battery has a voltage of 1.5 volts. The first part of the question, what is the voltage across X? Well, since X is in parallel, and we can see the path of a charge might flow like so, and that charge gains 1.5 volts of energy from the battery and has to spend it all on X, the voltage across X is equal to 1.5 volts. Likewise, the voltage across Y is 1.5 volts because components in parallel receive the same voltage. The second part of the question involves finding the current through X and Y. If there is 1.5 volts of potential difference across X, we go to our graph, we find 1.5 volts and we go up, and we find how much current would flow through it, 12 milliamps. So there are 12 milliamps of current flowing through here, flowing through X. Flowing through Y, let's find out how much current there is. Well, if we apply 1.5 volts of potential difference to Y, we get 6 milliamps of current. 6 milliamps. And the last part of the question asks us, or the second last part of the question asks us, what is the current through the battery? If there is 6 milliamps of current flowing out of this wire down there, and 12 milliamps down here, they must add up in this wire here. So the amount of current total flowing through the battery is 18 milliamps. And the final part of the question, the challenge part, says what is the total resistance of this circuit? It would actually be quite difficult finding out the resistance of Y. At that point, there's a quicker way to do it. All we've got to do is say this part of the circuit here must obey Ohm's law. V equals IR. The voltage of the battery, 1.5 volts, is equal to the current, which is 18 milliamps, so 18 times 10 neg 3 amps, times the total resistance, so 1.5 divided by 18 times 10 to the power of neg 3 is equal to 83.33 ohms. So that is the resistance of this circuit here. Since Y is a non-ohmic device, we would find that if we were to change the voltage down here, the resistance of the circuit would also change. And that is something you don't see when you have simple questions with simply ohmic resistors.